Hello. In this little video, I'm going to be covering a subject that is often overlooked when writing firmware for something, and that is this little piece of paper here, which is basically a data memory map or a reference sheet for where you're putting the variables in the available data memory and the pattern you're going to use to lay them out, which is an aid, general aid in writing your program, and it also helps you lay out the variables in a pattern that will reduce the repetition of code or duplication of code, and to help reduce the size of the necessary program and subroutines and number of subroutines to be able to do the calculations and operations you want to do on the data and variables you have. And one of the best ways to reduce the size of firmware and the subroutines and everything is to take a look at the types of data that you have, and if you're going to have a lot of similar data or sets of data in which you're going to be carrying out the exact same operations or calculations on, then it's often productive to lay them out in a repeating pattern in which you can call a subroutine with a specific step or a specific pointer to indicate which set you want the calculation to be carried out on. Like this little memory map that I made for the timer counter that I've been working on in a couple of the other videos I've already posted. Here's basically a general outline of the memory map, and I'll go over the reason I laid the different values out in the way I did, in a way that might be helpful to you when if you're writing a program, to give you a couple ideas and a couple hints that may be helpful. And this memory map, basically from 00 to 0F per line, all the way from 00 to 7F, which is the end of the 8051 memory range, which is 128 bytes, and of course 0 to 07 is the 0 to 7 register, and I'm going to be using 10 to 1F for the stack space. And here's where I start laying out my variables. In this case, I'm going to be having 3 identical, relatively similar counter chains, each comprised of 2 counters, one external counter and one internal counter. So I've laid out the memory map in that there's going to be one set of data for internal counter or external counter on counter chain 1, one set of data for the internal counter, counter chain 1, then next counter chain, and next counter chain. And that way I'll be able to direct the subroutine on which counting chain I want the calculation to be carried out on with a single register value, and laid out the final output counts and also a repeating pattern. That way, when I call a subroutine to take the values from each of the memory locations in register in the counter chain 0 and then put them to the final output. It can do all that with only one pointer register telling the subroutine which counter chain to calculate. And that way you reduce the number of subroutines and duplication of codes in the subroutines, because the subroutine does not care which counter chain that you are doing the calculation on. It just strictly takes the value that you give in the pointer register and uses that to fetch the addresses. For example, I've got external timer counter 0 starting at 20 hex. I've got external timer counter 1 starting at 22 hex. External timer counter 2 I've got starting at 24 hex. 26 hex is empty spot. The internal timer internal counter 0 starts at 28 hex. Internal timer 1 starts at 2A hex, and internal timer counter 2 starts at 2C hex, and the reference counts, which is the previous count that was pulled from the counter last count cycle, is stored 16-digit offset from the previous one, which is 30, 32, 34, 38, 3A, and 3C. And reload values for the external timer counters is stored at 3A, 3A, and 3D, or 3C, while the final calculated display values will be stored at starting address of 405060. How will a subroutine be able to automatically increment to each one of those with a single register value? Let's say I want to store a single register value in register 7 and then call the subroutine to calculate all the above and store it in the final display segment. When you do that, the value that I'd be storing in register 7 is a pointer value. It'll either be 0, 1, or 2 to designate the 3 counting chains and the final outputs that I want it to store at. So if I specified 0, 0 hex in the pointer register and then called the subroutine, then all it has to do is to calculate the primary base memory addresses is take that value pulled from register 7, shift it left once, which basically multiplies it times 2, and then adds 20 to it, and that would yield the base address for the memory location for storing timer counter 0. If you take that value, shift it left one step, then add 28 to it, then it would yield internal timer counter 0 base address, and then follow the same out for the references. Take 00, shift left, add 30, and you have reference for timer counter 0. Take base address 00, shift left once, add 8 to it, and you have base address for reference for timer counter internal counter 0, which makes up the internal which makes up the total counting chain 0, and then for calculating the output address, all it does is take the 0, flip nibbles, add 40 to it, and you have the starting address for laying out the calculated final display value. And say, instead of wanting to do the calculations for counting chain 0, let's say if we want to initiate the calculations for counting chain 1, you put a value 01 hex into 7, call the same subroutine, and what it would yield then is the 01, shift it left 1, which would be 02 hex, add 2 to it, you have 22, which is the starting address of timer counter, external timer counter 1. Then take the 02 and 01, add it poles from 7, shift it left 1 to be 02, then add 28 to it. You'd have a total of 2A, which is the internal counter 1, and then take, of course, follow through, shift it left 1, add 3 for external counter reference 1, shift it left 1, add 38 to generate 3A, internal counter reference 1, and when you take that 01 flip nibbles, you have 10, add 40 hex to it, and you have starting base address 500 for the start of the data array for the final count on counting chain 1. And if you put 02 to it, of course 02, shift left, you have 04, add 20 to it, which yields 24 hex for the base address of external timer counter 2, add 28 to it, generate 2C for the memory address to store data for timer counter, internal counter 2, add 3 for that, 3 for that. And when you take the 02 hex stored in 7 and you take flip nibbles, you have 20 hex plus 40 hex yield 60 hex for the start of base address of the data array for final displayed number for counting chain 2, and all those calculations can the memory locations for all those calculations can be carried out by a single subroutine pointed at with a single register without having to replicate code or duplicate code for any of the single counting chains stuff. So that way you can minimize, packetize the subroutine, and just basically it can calculate out the values based on a standard interleave that you use to lay out the code. And the other way I could have laid it out is have each of the timer counter chains occupying a 16-bit address spot in memory, and then just incrementing the 16-bit address spot for each of the counter chains in the subroutine, where you'd have timer counter, external timer counter 0, internal counter 0, the reference for those two, the reload value, and then the final count display value would have all fit in 16 bytes. But there's a particularity with 8051 and 8052 is that only the memory space from 20 to 2FF, 20 to 2FX is bit addressable. So this one little band of memory here is of a particular type that I really want to be able to keep the raw count value of all the counters in this space so that I can manipulate it with direct bit addressing, which if I laid it out with counter chain 0, counter chain 1, and counter chain 2, then I'd only be able to directly byte address or bit address counter chain 0, but laying it out interleaved like this with all the raw counts in 20 to 2F, then reference in 30 3F, and then the reload values 48 to 4F, and the final count display values 4, 5, and 6, 0 starting points. Then it allows me to keep all the raw counts, direct retrieve counts from the counter stages in the bit addressable region, which allows me a lot more flexibility in manipulating the data with the subroutine in question. While non-repetitive code, instances where you have a bit of data where there's only one type or one instance of that data, then you can store in areas not used by the other subroutines and can take and use direct addressing to point your subroutines to where to retrieve or to store that data. But for situations where you have lots of sets of repetitive data, then taking and laying out a memory map in such a way that you can basically design your subroutine around working with repetitive data with only having one subroutine of that exact layout and performing that exact calculation allows you to minimize code repetition and stuff while maximizing the functionality of the program and simplicity of it at the same time. So take care, take it easy.